I am Jean Joseph, based out of New Jersey, originally from Haiti. You can feel that there is a Creole or French accent. Yeah. So therefore, I am aware that I have an accent. If I did say something you didn't get it, feel free to raise your virtual hand. Tim is right in front of me. Once you raise your virtual hand, I'll be happy to stop and go over the questions. I work for Microsoft as a technical trainer, mainly focused on data and AI. I am a data guy, right? And I've been contribute to this community for so long, since 2014. I heavily involved in the data in terms of development, high availability, performance tuning, and everything. But now, since last 3 years, I've been talking about AI, even though our main topic today is focusing on the data pipeline. I know we only have 1 hour and I have a lot to talk. Okay, let me walk you through our expectation for today. Um, uh, I will do a brief introduction into the data pipeline, go over the concepts, and then explain to you why you might think of choosing Microsoft Fabric to design your end-to-end data pipeline, and then go over the benefit of a framework, right? Because sometimes business doesn't really know what they're looking for. Over time, things change. How can you build your data pipeline very flexible to handle changes and value? And then after that, at the end, I will share some best practices with you regarding the data pipeline implementation, things you need to consider and everything. So with that, I hope you and I are on the same page. I'm going to go over our main topic. Speaking of pipelining, what exactly is a data pipeline? Right? If you ask that question, I'm glad you did. And that's the same thing I've been asking myself, right? A data pipeline is a series of automated processes that move and transform data from various sources, such as databases, APIs, or files, right, to a destination where it can be stored and analyzed. It's involved data ingestions, where data is collected from the sources, followed by data transformations, where the data is cleaned, filtered, and formatted, right? The transformed data is then stored in a data warehouse or data lake, or even another storage systems, right? Ready for further processing and analysis, such as um, uh, for analytic machine learning or visualizations, right? Using dashboard and report. So now a data pipeline is a logical grouping of different steps, either in series or parallel, that allow you to perform different kind of tasks, transform, ingest that data, transform it, and store that data. So why do we need pipeline, first of all, right? Pipelines are critical because they automate the collections, transformation, and loading of data, reducing manual effort and error. They ensure data is processed quickly and efficiently, enabling real-time analytic and timely decision making, right? Data pipeline capable of handling large volume of data. Pipeline supports scalability of data graphs, right? They also maintain data quality through consistent transformations and validation processes. You Pipeline allow you to integrate from multiple sources for a unified view. That's exactly the purpose of pipelines, right? And ensure data is available when needed. So, which is essential for making informed business decisions, right? Pipeline can be implemented either using what we call ETL, which stands for extract, transform, and load, right? Or ELT, we stand for extract, load, transform. And sometimes we might need to hybrid them, right? So if we have to focus on the ETL part, is that this is the traditional way we use when the transformations of the data needs to happen before it's loaded into the data warehouse, right? Often due to the limitation of the target system, right? But if the target system is well equipped, right? If we think now we're dealing with distributed system, so ELT might be more suitable, and ELT stand for extra load transform, right? It's more modern approach that leverage the computational power of modern data warehousing to perform transformation after the data has been loaded. If we have to go over a hybrid approach, right? So it might be used when certain transformation need to occur before loading the data, and other can occur after, for example, loading the data. So this approach provide flexibility and can be tailored to specific needs of your data infrastructure. So depending on the specific requirement and capabilities of your data infrastructure, you can choose the most suitable approach that fits your need, right? So here's the thing. What would be the benefit and challenges of data, of dynamic data pipeline? Because everything has a pro and cons, and we need to balance both of them. Let's focus on the benefit of data pipelines, right? So data pipelines offer significant benefit in terms of scalability and agility, sorry. So they can efficiently handle increasing volume of data, allowing business to grow without being constrained by data processing limit, right? This scalability is crucial for organizations that need to adapt quickly to changing data requirement and business needs, right? Facilitating the rapid integration of new data source. Additionally, if we still have to focus on the benefit, is that data pipelines support different data modalities, processing various data types, including structured, semi-structured, and unstructured data. This versatility enhancing the comprehensiveness of data analysis by integrating diverse data sources, making the data more useful for analytic and decision making. What about reliability, efficiency, and utility are other key benefits of data pipeline. Automated data pipeline reduce human error and ensure consistent data processing, which enhances reliability. They streamline data flow, reducing latency and improving processing speed, though increasing efficiency, right? High quality data, processed data is more useful for analytic and decision making, providing valuable insight that drive business strategy. In terms of benefit, we can even think of continuous monitoring, event verifications, and improvement. So these elements ensure data quality and integrity, allowing the pipeline to adapt to new requirements and technologies, further enhancing its utility. In terms of thoughtful selections, right? Because we have a tons of tools, sometimes it's hard to make its selections, right? and what would be the best technology for our data pipeline, right? So thoughtful selections of tools and technologies for data pipelines allows for tailored solutions that meet specific business needs. Customizations ensure that the chosen component optimize performance and cost effective, because we cannot ignore cost. Cost is normally a big factor of variables, right? So regular verification and improvement processes enable the pipeline to adapt to new requirements and technologies, ensuring it remain effective and relevant. So this adaptability is crucial for maintaining the pipeline's utility and ensuring it continue to meet the evolving needs of the business. Yes, those are the benefits. What happens if we have to focus now on the challenges of the data pipeline and revisit each concept, right? What would you think is that despite their benefit, data pipeline comes with several challenges. Scaling a data pipeline can introduce complexity, and managing and maintaining the infrastructure, right? Wait, as the volume of data increases, so do the costs for storage and processing, making it essential to balance scalability with cost efficiency. So those are the things we normally face, right? Ensuring capability across different data format and sources can also be challenging, as different data modalities require specific transformation processes, complicating the pipeline. You and I know what I'm talking about and how difficult this can be. If we have to think of reliability and efficiency, right? They require ongoing maintenance and monitoring, which can be resource intensive. Efficiently managing resources to avoid bottlenecks and downtimes is crucial, but can be difficult to achieve, right? Even continual monitoring and improvement processes, while, while beneficial, require significant resources and expertise, right? Implementing effective monitoring and verification processes can be complex and time consuming, adding to the overall challenge of maintaining a reliable and efficient data pipeline. The vast array of available tools and technologies can make it difficult to choose the best ones for a data pipeline, right? Decision making in the in this context require careful consideration of the specific needs and constraints of the business, ensuring seamless integration between selected tools and existing system can be complex, requiring significant effort and expertise. Additionally, the continuous need for monitoring, verification, and improvement adds to the complexity and resource demands, making it a challenging but essential aspect of managing data pipeline. So now we know what is a data pipeline, we know the benefit of it, and we know the challenges, right? As the dynamic pipeline we will build for Contonso company will be built on top of Microsoft Fabric. Let's see, for example, how Microsoft Fabric data pipeline can assist us. Let's see that. You know, Microsoft Fabric offers a comprehensive suite of tools and services designed to address both the benefits and the challenges of data pipeline. Microsoft Fabric is a unified data platform that integrates various data services including data engineering, data warehousing, data science, real-time analytics, and business intelligence. It aims to provide a unified experience for managing and analyzing data across different modalities and sources, right? Microsoft Fabric offers robust support for data pipeline, enhancing their efficiency and scalability. It allows for seamless data integrations and transformation with minimal code, leveraging metadata driven, right? So this approach reduces maintenance and increase scalability, making it easier to handle diverse data sources and format. Fabric integration with Azure DevOps also facilitate collaboration, development, and source control, ensuring that data pipelines are managed effectively and consistently. One of the key benefits of using Microsoft Fabric is its ability to connect to a wide variety of data store, including on-premises data source, cloud databases, and business applications. So his versatility ensures that organization can integrate data from multiple sources into a unified pipeline, providing a comprehensive view of their data landscape. Additionally, team Microsoft Fabric graphical user interface simplify the creation and management of data pipeline, making it accessible even to users with limited coding experience. Moreover, continuous integrations, monitoring, and improvement are integral to Microsoft Fabric's data pipeline management, right? The platform supports real-time data processing and verifications, ensuring data quality and reliability. By enabling efficient data movement and transformation, Microsoft Fabric helps organizations derive actionable insight from the data, ultimately driving better decisions making and business outcome. So now we know what is a data pipeline, right? We know the advantage of a data pipeline. We know the disadvantage of a data pipeline in terms of challenging and complexity. Now we just discover how Microsoft Fabric can overcome the challenges. Okay, what are the key concepts, team, of a data pipeline? And whatever I'm about to say apply for Synapse pipeline or data factory, right? Except that on the Fabric, there are some exceptions with regard to data set and the integration one time, which I'm going to cover with you as well. Let's go step by step. Let's break this down. Each component in the context of Microsoft Fabric Data Factory. So the first thing we're gonna heard is what we call link services, right? Link services in Microsoft Fabric, also known as connectors or connection, right? Link your data stores. So they function similarly to link service in Azure Data Factory, but offer a more intuitive way to create and manage them. For data set, right? In Microsoft Fabric, the concept of data set is not applicable. Instead, connections are used for connecting each data source and pooling data. In terms of activities, is that activities in Microsoft Fabric define action to perform on your data. Microsoft Fabric support data movement activities, data transformation activities, okay? And also control flow activities. If we have to focus on the data movement in Microsoft Fabric involves transferring data from various sources into a single data lake where it can be stored, analyzed, and visualized. If we have to think of transformations, right? Because data transformation in Microsoft Fabric involves cleaning, prepping, right? And transforming data using a low-code interface, and over 300 data and AI-based transformations are available to us. In terms of control activity, is that it involves managing the flow of data and orchestrating the executions of activities in a data pipeline, right? I've been talking about pipeline since we start with this, with my session. And by now, you and I can agree that pipeline in Microsoft Fabric are logical grouping of activities that together perform a task, right? They allow you to manage, extract, transform, load activities instead of managing each one individually. In terms of schedule, right? Fabric can use the schedule feature to automatically run pipeline, right? We can think also of what we call integration one time. In Microsoft Fabric, keep that in mind. There is no concepts of integration one time. So the executions of the pipeline is managed internally, right? However, Microsoft Fabric operates within the Power BI environment, integrating technologies like Azure Data Factory, Synapse Analytics, and Power BI into a unified product. So this allows data and business professionals to unlock the potential of the data within a familiar interface. The 14, Microsoft Fabric integrate with Power BI Gateway, which are crucial for connecting cloud services to on-premises data, either via on-premises data gateway or VNet, right? On-premises data gateway, these act as a bridge, providing quick and secure data transfer between on-premises data and several Microsoft Cloud services, including Power BI. They allow organizations to keep databases and other data source on the on-premises network. How cool is this? Yet securely use that data in cloud services. If we have to go a little bit over the VNet data gateway, is that these allow input or direct query semantic model to connect to data services within Azure Virtual Network without the need of on-premises data gateway. Yes. In Power BI, VNet Data Gateway require a Power BI premium capacity, right? License. They securely communicate with the data source, execute query, and transmit result back to the service. So now we know exactly what is the different type of data pipeline, okay? And we also know when to use one versus others. We know the advantage and challenges and how Microsoft Fabric can help us overcome this, right? Moreover, we know all the concepts we need to be aware of in order for us to be able to implement a metadata-driven pipeline in Microsoft Fabric. So now let's consider ourselves here as a consultant. We are a consultant, okay? Consider Contanso company has a job requirement. And the first thing you have to understand, you will work with internal IT team, okay, to onboard new clients. So what they expect you to do is that they need to have a pipeline as to feed the TNet system. You know, a TNet, if you ever worked for consultant, you know what I'm talking about. When I used to be a consultant before I joined Microsoft, sometimes they might send you out to work with a client. That client have N numbers of clients sign up with them. And sometimes they have the same schema definition, but the content of the data is different. During the loading of the data, you have to load that data in order for you to be able to populate that data for the right client, even though it is the same schema definition, but different content. But you know, you and I know, customer never know, okay, their job requirement. They never know that. They never have a clear understanding. That's the reason as a consultant, sometimes what make us shine, because we go with information first. We will not start building anything without any information collected, right? Where both parties sign. That's the difference between internal IT and a consultant, right? So now the basic requirement is that one or two new customer who will provide the same data structure but with different content. We have to ensure we load that data quickly, and we're not sure about the full expectations. Anytime when you heard a business stakeholder say this, all I have to do is extract more information and make sure my data pipeline can handle changes in volume. Because with that, I will not have any full insight on the workload. So therefore, doing the documentation, I might mention so and so might be under or over provisions just to cover myself. But doing the data pipeline implementation, I need also to leverage what we call a framework. But 90% of the time, we don't start that way, right? And I will show you how we start, and I will raise that level to 400. So if you see here, perfect. Consider this is the initial requirement. The first requirement, they said we have two new customers, so we need to load that data. Our first intention would be to launch Microsoft Fabric. Okay, for those of you that never see Microsoft Fabric is a combination of multiple persona. If I click here, you will see this is Fabric. Okay, that's Microsoft Fabric. Under each persona, you can see if we want to perform data movement, we have two persona that can allow us to do that. We have data factory, and then we have data engineering. So if we click on data factory, you may notice that we have what we call pipeline right here. This is pipeline, okay? And then if we click on the under data engineering, you may notice that we should have pipeline as well, which is pipeline, right? Our first intention is to click here, okay, and add a copy. That's going to be our first way thinking, because they may say it is just one or two times, and that's it. We will never receive it. Okay, but at the same time, they will tell you, I'm not sure because I don't have the full expectation. So now, what I'm going to show you is that I have this pipeline. The first thing we will be doing, okay, is navigate to Fabric, either under data factory, persona, or data engineering, create two copy, okay, and then go on source, define the source. You see here, this is the file. Let me show you the file. This is where we are receiving that file. Okay, so now that's the file, but for now, consider it is just for two files. We're gonna configure, for example, our connector to be able to connect to our data lake, right? Or blob storage, get that data, and then load it to our data warehouse. If you see here, this is kind of um, um, two copy data. Okay, consider you execute this. I'm going to execute the second package because that's very basic. Okay, consider you execute this. When you execute this, you send it to business. Business validate, they're happy, and they send it back to the client. The client say, oh, I'm happy. And now the job requirement change. Okay, and they said, I'm happy. That's exactly what I was thinking. Now things change. Okay, so now what they want, they anticipate multiple files for each client. Okay, and they said, be aware that new client may be added. And if new client may be added, so therefore we cannot rely on what we call keep on adding copy activities. That will not work. We will reach to a level, it will be too much, right? So we will need a way to control that. And they said they require Apache Spark, but that's fine. Where I, I want to spend more time is what we call they want to log the executions because they want to make sure they monitor the execution times. And if they are a failure, they want us to send that email to internal IT and business stakeholder. Okay. And guess what happened? So now they also need to archive. So if if the anticipation require multiple files, so there must be a way for us to, for example, load that data more efficiently. Okay, so this is where you might need to think of creating a framework. So what I mean by creating a framework is that that's where you might need to think of having a table metadata driven. This is what a framework is all about, right? Because metadata driven is a method of data processing where the metadata drives the processing of the data, right? In metadata driven data pipeline, a control table is used, and that control table contains information about how the executions of your pipeline should be done. It will drive that execution. So it has all the parameter value, okay, for things like the name of the server, files, database, and objects that are involved in the data pipeline. So the queries or procedures that are used to extract and load the data. And we also need to have a retry because the retry and schedule options, we have to be able to handle that. The number of concurrent or subs or sequential tasks, right? And the environment, right? Development, quality assurance, or productions normally maintain different metadata driven value, right? So that where you might need to think of coming with an approach to control the file. If you recall some of the job requirement, when the business like what we just did say, they have to be able to load, to exclude the file, even regardless if the file exists on our data lake or FTP, right? So that's where we might need to think of having a control table to maintain the behavior of our pipeline. So this approach has several benefits, such as it enhances flexibility as you can easily change the source and the destination data store, right? The copy behavior and the loading mode by updating the metadata without modifying the pipeline. It's improved maintainability as you can parameterize link services or connector and even data set outside of Microsoft Fabric because Fabric does not support data set in a single generic pipeline to handle multiple data source and sync. rather than creating multiple objects for each one. What it allows you to do also, it allows you to increase scalability as you can use a control table to store the list of objects to be copied and the metadata and use the parameters pipeline to read from the control table and apply the copy logic accordingly as I'm about to show you. So I'm going to walk you to that environment. So this is a very basic, okay, very basic system that I quickly create just to show you how to implement it, and every code are available on my GitHub. So I'm creating a schema, and within that schema, call it metadata. You might see I have all of them right here. I already did them for you, so you don't have to watch me doing this. This table, what it's going to hold, team, it's going to hold the server information, right? So I need a server ID because each application requires a compute to be executed. I want to know exactly what's the name of that compute. And each, for example, um, uh, application we register will require a data store, either a lake house in the context of Microsoft Fabric or a data warehouse, right? So we have to track that. So this is the server name. This is the date we registered this. Within the application, we have an application ID, and we bring what we call the server ID. The application name is active. The reason why we put this is active is that if you recall, one of the job requirement business want to be able to deactivate a, uh, a data, a file, not to be able to load regardless if that file is available. So in that case, if they don't have contract with a client, and they want to enable the complete load for that client, I have to give them a way to automatically update the table control and remove that application from being part of that process. And if that client rejoin again, all we have to do is reactivate this. And you can see this is a bit and byte. We set this to 1 by default, which is mean that automatically we insert that application record, it will be active. So if we want it to be 0 during the insert, we can predefine that 0. So what I'm doing here, I need the storage, right? Within that storage, I need to know what application it's belong to that storage, right? For me to be able to identify the owner of that file. I have the name, the extension, the container, the storage endpoint, the incoming. If you click here, you will see that incoming. This is the incoming. This is the place we will archive that. And this is the work area for the archiving process. So I have everything here. Oh, sorry about that. Under uh, control everything outside of my pipeline. Okay. This is the archive directory. This is the archive work area directory. This is the one link directory, right? And then this is active. The reason why is that if you see there is file name, remember they said we have to be able to prevent a file from being loaded, regardless if it exists. Not only we give them access to disable a file, but an application as well. And then in here, what I'm doing, I'm using this table control. I have the application ID, the schema name. This table, I have it just to show how you can do an end-to-end data migration without human intervention. And then this is a script that I to this will hold to create the schema if it doesn't exist. So this will give me a chance to create the table. If it doesn't exist, this will give me a chance to insert some of the metadata that will drive the migration process after the loading is done. So that's the reason why we have this here. So if we come back here, you may notice that we have a couple stop procedure that we created. And the first stop procedure is the one that will, for example, get the metadata. If I go look at the definition, you will see that during the definition, I want you to pay close attention, we have where the file happen to be active. So if the file is active, we will load the file. You can see we are performing some complex operation here to prep the metadata, and that I can put that into a what we call a kilocode. So, and we also have to track the error message. If you see here, this is the error message. Okay, we think the error message, this is what we have, and along with the process log, this is what this script is doing. So now we have our metadata handy. How can we design that? If I go back here, Tim, I'm gonna go back here and go back to my uh, workspace. Okay, I'm gonna click on second one. What I want you to understand, I'm gonna analyze this first. In order for me to make it metadata driven, I need to be able to access this store procedure. If you recall, this store procedure, let me show you this. It is the one that have all the metadata. Let me show this to you. Okay, it has all the metadata, the information, where the file is located, as you can see, the storage endpoint, the root, you can clearly see, and it has create schema. If the schema does not exist, it will go and provide us the script to execute it. And then if the table does not exist, what I'm doing, extracting the current schema definitions, okay, uh, uh, or explicitly mention the schema definition and have it create that table, right? And then this is the process ID. Why am I having a process ID? Because I have to be able to identify each run. So this, it's kind of a single experiment. So once it's executed, if it's fair, instead of relying on the log ID, I relying on what we call a process ID. Because if there are 10,000 files, all 10,000 files linked to one process ID. So in terms of troubleshooting and documentation, that process ID will give me tons of insight. So that's the reason why I create that process ID. Okay. So now what I'm going to do, I need to be able to retrieve that information and pass that information to my data pipeline. So for me to do that, I need a lookup. So I have a lookup. I set up my lookup, set up my connection. If I test that lookup, you will notice that it should go well. So now it's fully tested. So now within that lookup, when I'm configuring that lookup, is that I can preview that data. So doing the configuration, if you notice, there is a table, there is a query. I said stop procedure after I set up my authentication. Great. So now this is the same data we were seeing from Azure SQL database. How can I pass that data as an array? In order for me to alter it over that record, what I need to do, I need a for each loop. And how can I get that for each loop? I can click here and type for each. So I got that for each loop. Okay. So now within that for each loop, I need to pass over that data as an array. When I click on setting, you may notice that I pass that as an array. If you click here, you should see this is the query table control. And then give you once again, this is what this is the information that we need. We need that array. That's the information. So by having that data, so now I have that data here, see, okay, but I will need to loop to that data. So by looping to that data, if I click here, you may notice that I have a couple variables. This one is where I need to track the start time because we have a logging process in place and time. This one is where I will dynamically generate a query to log that data. And this one is where I will dynamically generate a query to get the failure information in case if something failed. So if you notice here, what I'm doing here is that I will need to get the start time. Okay, if I click, I have a set variable here, and then I set that variable using that date for format. So, right, that's what I'm doing. And for and here I do not want to blindly go access that file. I would love to check if that file exists. So I'm using get metadata. If I go to the setting, you may notice that I am dynamically passing the information that I got, that my lookup, my for each loop is looping through, or okay. And then I'm checking if it exists and returning the item name. Okay, so this is the data where I'm loading that data to my lake uh, to my lake house. This is the destinations. That's the table name. But here's the thing, team. I will need to get the completion of this. By getting the completion, if you notice here, the completion is is uh, using another variable, and the precedence is not failure or succeed, it is incomplete. Because if I put this succeed like this, and this one, if it fail, will not execute. I want to capture how long it takes before the failure occur, right? So therefore, I'm using a completion here on completion. In here, I want, for example, to proceed with the process log if and only if it is succeed. And I want to proceed with the error log if and only if it's failed. And then within the process log, if I click here, go on dynamic, you can see I am using the metadata to dynamically, okay, load that data, and dynamically create that data, and using what we call a, a script task, and pass that script task and connect to my um, uh, database and log that information. And I'm doing the same thing here as well. If I click here, what I'm getting here, team, I want you to notice I'm getting the error message, right? So now you understand this, what I'm doing here, executing this. Let's execute this. I want you to notice that it is executing. So it's going to grab that information from SQL Server using the key lookup. And then after that, it's going to go and load that data. So we're still on time. Don't worry. And this might take about 45 seconds because the data size is so small. This is a demo. The concepts is what I want to share with you. So if you see here, it's looping through each activity, get the time. Okay. If you see, check if the file exists. This is what it's queuing now. Now it is in progress. So therefore now what it's going to do is to load that data. If you see here, the loading data is queuing. Okay, so we just have to wait for a few seconds. The execution should be done. So it's queuing. You can see it is in progress now. While it is in progress, I want you to notice that it's still in progress. Okay, some of them are completed, as you can see. It goes and load. If you register 20,000, it will go and execute 20,000. And the good thing is, when you click on that for each loop, you have the possibility to make it sequential if you want to. It wants in parallel because I did not check the sequential one. So hopefully this is completed. We still have one to execute, or what is execute is logging the data. So now I think if we refresh this, it should be able, for example, to say complete. So yeah, it is complete. If I go back right there, team, okay, what I'm going to do, get the max, for example, the max process log, and execute that. And I want you to see, we have, this is today, the data load, okay? So if you see everything is today, we can see how long each one takes because they ask us to provide the durations. We have the start time, the end time, and then we have the load date. Okay, we have the number of records that is being copied. We have where we archive it. We get all information that we wish to have, right? So now let's force a failure, team. I'm gonna show you something. Now, if you recall here, we have 5 records returned. Let's force a failure occur. Let me go back here. Let me update this. I'm going to update this. And we know data type is a big issue. I'm going to add A here, and I'm going to save it. So we know this is byte bell. Okay, once the saving is done, it is done. I'm going to go re-execute this again. I want you to notice. I'm going to re-execute this. I want you to see doing the failure while this is executing. If I go back and query any failure for today, we should not get nothing. It should be things that I tested yesterday. If you see here, everything comes. I'll give you 1 second. If you see here, where is this one? So where is the failure? Failure. Okay, perfect. So this is 9. If you see it, the process ID is 9, as you can see. The process ID is just 9. So let's wait. So now let's see if it's completed. So now it's loading the data. So we should have one file fail. We do. And then if I go back here, if you recall, everything is 09. Let's execute this. You should see that we have, oh, it's had not logged yet. Let's wait until the execution is done. Okay. So now if we go back here, is that we execute this, we should see we have one failure. Okay. And if we mouse over to that failure, I want you to see on the right inside is that the value is 63A. It tells you, okay, why it is failed, because we capture that information, right? So now here's the thing. What happens in if we rename the directory? Let's go and rename the directory. I'm going to go and rename the directory. By renaming the directory, I want you to notice that now, let me quickly copy this because we have time. I want you to notice that I'm going to rename it 1, okay? And I will show you that this, when we handle data, is totally different, but we have to also handle the directory issue. Just give me one second. I'll go over the questions. If I go back here, we know we just renamed the directory, so that directory does not exist. I want you to see if I execute this, take a look of how our pipeline is suffering because the directory doesn't exist. We didn't handle that. So when you're making your data pipeline, metadata driven, it is ideal to handle one-time issue related to data and related to your infrastructure. Like if the storage change, you don't need to make your data pipelines suffering. So now we are executing this. So the data load is processing. You will notice that everything will fail because of the file does not exist. Just give it a second. We should see it's failed. So take a look. So now if we have 1,000 files, we're gonna have from our log a tons of error message, which is not good. And if we go here, we query this, give me 1 second, you will see that we have those informations and the file does not exist. If I mouse over here, you should see the information stating that the directory does not exist. So what we can do now, instead of leaving it this way, which is great because we handle the error for the data, but we have to handle the error if the directory does not exist or if our pipeline cannot authenticate to Azure data or block storage or any external data connector. We should prevent our data pipeline from suffering. So what I can do now, I can change the architecture a bit, which is a little bit kind of the same, but handle it more mature, right? So this is the same lookup. And then inside of my for each loop, instead of designing my data processing. I changed the architecture a little bit, the design a little bit. So I'm still checking if it exists, get the file name. And now I'm using a if conditions. So that if conditions, you may notice there's a true here, there's a false here. So therefore, if the file does not exist, it will go send me an email. If the file does exist, it will go and process this. Let's verify to see if we're gonna get that many failure on our process. If I execute this, I want you to notice that it is executing. Now there will be zero failure. However, it will email me along with the business stakeholder the way business have requested it. So with that, so let's this execute. Let me go over the question a little bit. Is that okay? Seems like it's not a question. Our next sessions. Okay, perfect. That was just a statement. Okay. Perfect. So now if you see here, let's wait for the data processing. So it's sending email. There is absolutely zero error message from our log now. But instead, it sent email. It's let us know that there is a failure occur. So that's going to be the difference. So if we have to summarize, team, is that we have a lot that we can talk. I'm gonna just summarize is that how can I quickly summarize this into what we call one sentence is that when building a data pipeline, it's crucial to treat it as a project, employing agile methodologies for interactive process and continuous feedback. Engage stakeholder regularly to ensure the pipeline align with business need, right? Building incrementally with a modular design allows for independent testing and deployment of component, while versioning control system like Git facilitate collaboration and changes management, right? Comprehensive documentation supported by automated tools, okay, and ensure that every aspect of the pipeline is well documented and easily accessible, right? Incorporate data catalog into your engineering strategy is essential, team, right? For effective metadata management, tracking data lineage, provenance, and usage tool like if you think of the table we just mentioned, we can even bring in the picture what we call purview, if we have to think of, or Apache Atlas, right? That can help maintain an organized inventory of data asset. So I will not spend too much time because we already out. Or when you're building team, I forgot to mention that build to minimize costs. That's the key. And I think that's the conclusions. So what I mean by is that if I have to conclude is that automating data pipeline with data-driven framework in Microsoft Fabric can help streamline the process of building and managing data pipeline. By using metadata to describe the pipeline, developers can focus on building the pipeline logic rather than worrying about the underlying um, um, for example, complexity that is exists. And this can lead to increased productivity, reducing even development and improve data quality because we can reuse the same data. So I hope you learned something out of this. So I think it's my time to go. So it was a pleasure to have all of you. If you have a question, you have my email. So if there is any session evaluation, I would love to get your evaluation. So with that, I'm gonna stop here and pass it over to the next speaker.